So good morning students, welcome to another session on design of machine elements. Today I will start with the quote of APJ Abdul Kalam. You cannot change your future, but you can change your habits, and surely your habits will change your future. So today we will study a new design portion, that is design of V-belt. First we will compare what are the advantages and disadvantages of V-belt when compared to a flat belt. V-belt usually designed for transmitting power over short distances, whereas flat belt can be used for long distance up to 15 meters. Further, we can see that flat belt can have higher efficiency and it also has higher power transmission capacity when compared to V-belt. However, these belts cannot be used in vertical direction, whereas V-belt can run even when the belt is vertical, which we can see in our automobiles. Now we'll see the design steps for designing a V-belt. Answer this question. Select a V-belt to transmit power equal to 10 kilowatts at 750 rpm from a motor to an exhaust fan at 250 rpm. Exhaust fan is rotating at 250 rpm. Center to center distance is approximately 1.2 meter. Pitch diameter of the motor pulley is 200 mm. So the motor pulley is rotating at a higher rpm and its diameter is given as 200 mm. So there are two pulleys. There is a motor pulley and there is a fan pulley. Motor is rotating at 750 rpm and fan is rotating at 250 rpm. They are connected by a V-belt. So this one is a larger pulley, capital D. This one is a smaller pulley, small d. Small d is given as 200 mm. It is given. So our first step is to select the diameter of the pulley. We have already given the diameter small d, then we have to find the capital D. So our equation is capital D, diameter of the driven pulley, capital D equal to 1 minus epsilon into di. In this case, power equal to 10 kilowatts, and since no service factor is given, I can use this power for all the calculations. So power equal to 10 kilowatts. Further, it is given small d equal to 200 mm, and equation for capital D equal to, which can be found from 1 minus epsilon di. I will rewrite that equation, 1 minus epsilon di. You might be remembering from the previous lectures, epsilon was the slip, percentage slip, which is not given in this question. Small d is the diameter of the smaller pulley, which is given as 200 mm, and I is the velocity ratio, that is 750 by 250 equal to 250 equal to 3. Since percentage slip is not given, I will consider that value equal to 0. So assume percentage slip epsilon equal to 0. I can get this equation, capital D equal to small d into I equal to small d equal to 200 into I equal to 3. I will get 600 mm. Now we have to standardize these values. I have already got that value small d equal to 200 mm, and check in this table 14.13b, there is a standard value small d equal to 200 mm, so I can directly select that value. For the capital D was obtained as 600 mm, so from this table I have to select a value which is greater than 600. So after 560, the next standard value is 630. I will select this value as a standard value for capital D. So standard dia, small d equal to 200 mm, capital D equal to 630 mm. Further, I can find the pitch length of the belt. Here, center to center distance, the approximate value is given as 1200 mm. Capital D is known, 630 mm, and small d equal to 200 mm, standard values. After substituting all this value, I can get capital L equal to, is only an approximate value, 3741.62 mm. But we have to standardize this length because V belts comes in a standard dimensions. So I have to standardize this length of the belt, for which I have this table 14.20 in page 323 and 324. Now in page 324, as a continuation of what it is given in the page 323, I can see that for our required value 3741.62 mm, that was the value obtained from the calculation. My standard value will be, after 3658, my standard value will be 4013. So this is standard pitch length L equal to 4013 mm. So I will rewrite that value. Standard length L equal to 4013 mm. After finding the length, now we can find the actual center to center distance. In this equation, actual center to center distance A equal to C equal to A plus root of A square minus B, where these values are already known. L equal to standard value, which is 4013 mm, 4013 mm, capital D equal to 630 mm, and small d equal to 200 mm, all standard values. I can substitute in this equation, and after substitution you will get A equal to L by 4 minus pi into capital D plus small d by 8 equal to 677.3 mm. Further, B equal to capital D minus small d by 8 whole square equal to 2889 mm square, and C equal to 1352 mm. After substitution, you will get the standard value C equal to center center distance between the driver and the driven pulley. So this is a motor pulley, this is a fan pulley with the capital D, and this one is small d. Center center distance C equal to 1352 mm. Then we can find the angle of contact, which is very similar to which we have seen in the flat belt drive. Here we can substitute those values. Capital D equal to 630 mm, small d equal to 200 mm, and C equal to center to center distance equal to 1352 mm. You will get theta s. Here theta s equal to pi minus 2 into sine inverse d minus d by 2c, where theta s is the angle of contact for the smaller pulley. So there is a larger pulley and a smaller pulley. In the larger pulley, the angle of contact is theta L, where the belt makes in contact with the pulley, and this is theta S. Theta S equal to I write this equation. Here I should write theta S equal to 180 degree minus 2 sine inverse d minus small d by 2c. So I will get that value is equal to 161.71 degrees for the theta L equal to 180 degree plus 2 sine inverse d minus small d by 2c. Here note that pi is replaced by 180 degree because 2 sine inverse d minus d by 2c, this value will get in degrees. The second term will be in degrees. So we should substitute this value pi radians equal to 180 degrees. 180 degrees. So after substitution, theta L will be obtained, and theta L equal to 198.29 degrees. So I got the value of theta S and theta L. Now we have to select the type of belt. So there are different types: light duty, medium duty, heavy duty. Our required power was 10 kilowatts. So we should find, is there any wordings which is related to kilowatts or something in like applications. I can find for fans over 7.5 kilowatts, I have the second row of values. It is given over 16 hours of service. It's not mentioned type M or type N. I will select type N. So assume type N. From this table, I will get this value as the service factor Ks. So design power equal to normal power into Ks equal to 10 kilowatts multiplied by service factor 1.4. This service factor equal to 14 kilowatts. After getting this power, I need to find the type of belt. So when you get the power range equal to 14 kilowatts, it can fall in these two ranges. So we can take either one of them. Here I am selecting the type B because my 14 kilowatts will be in between 1.5 and 15 kilowatts. So I select type B. So for design power equal to 14 kilowatts, I am selecting V belt type B. V belt type B. So this completes the first step. Now we are coming to the last step, the most important step, number of belt. Equation 14.14, page 295. So in this page, I have the equation number of belt required N dash equal to P into Ks by Kw, Kl, Ka. Most of the values are known. We will see how it will look. So N dash equal to P into Ks. Power is known in this equation. power equal to 10 kilowatts. We have already found the value of service factor Ks equal to 1.4. So this completes our numerator. Now we will find the denominator Kw. Now we see here for type B, my equation for Kw equal to this equation 14.13b, where velocity can be written pi dn by 60 equal to pi into diameter of the motor pulley 200 mm 0.2 meters diameter into its speed 750 rpm divided by 60, you will get 7.85 meter per second. So we have got this velocity. Now the only one we have to find in this equation is dE. D is the equivalent diameter. Maximum value of equivalent diameter is 175 mm, which is given in this equation. And there is another equation, dE equal to D into KD. So we have to consider these two equations. So from table 14 point, from this table I can find the maximum value of dE can be up to 175 mm, and the second equation is D into KD. I have to find this value also and consider the minimum value. So I will find D into KD. In order to find KD, there is a table given here. In table 14.15, I can find for speed ratio greater than 2.9, our speed ratio was 3, speed ratio equal to 750 by 250 equal to 3, which comes in this range, for which KD equal to 1.14. So substituting that value KD equal to 1.14 in this equation, 1.14, and small d was equal to 200 mm, I will get equivalent diameter dE equal to 200 into 1.14, you get the value 228 mm. Further, from page 295, that is from page 295, equation 14.13b, maximum value of dE was 175 mm. Maximum value dE was equal to 175 mm. So I have to take the minimum value among this value. Minimum value. So this one is the minimum value. So I will select that value for the calculation, 175 mm. So we have already found the value of velocity. Velocity was equal to 7.85 meters per second. So I can substitute in this equation d equal to 175 mm and velocity in all the cases equal to 7.85 meters per second. So I can get Kw equal to 2.8 kilowatts, 818 kilowatts. Now we will go to the next equation. So we have to find the number of belt. So we have found the value of Kw. P is known, Ks is known. Now the only thing we have to find is KL and K. And there is another thing. P into Ks, this is the power to be transmitted. Power to be transmitted. And the denominator as such represents the power transmitted by one belt. So number of belt required will be equal to required power divided by power that can be transmitted by one belt. So we can find the value KL and KA. all the values are given. KL is the correction factor for length from table 14.20 and K is the correction factor for the angle of contact or arc of contact 14.21. From table 14.20, this is a table in page 323. You can refer that. My standard value was 4013 mm. 4013 mm. So this is our value. And type of belt was B. So take the second column. So this will be the value of KL. So KL equal to KL will be equal to 1.13. Now the only remaining term is value of Ka is 1.13. For arc of contact, I have this table in which the arc of contact for the smaller pulley is given in degrees. My obtained value for theta s was equal to 161.71 degrees, which will be lying in between these two values, 163 and 160. Now we have two columns, VV and V flat. And what is VV and V flat? VV means V belt. If it is running over a crown pulley, it is called a VV. If the V belt is running over such a pulley, it is called VV. If V belt is running over a flat pulley, it is called V flat. Now, how to select whether we have to select choose V flat or VV? At the bottom of the table, something is written in very small letters. It should be noted that advantage of V flat diminishes increasingly for arc of contact greater than 133 degree. So, V flat is best. V flat is best suited for arc of contact less than 133 degrees, whereas VV can be used for higher values. For greater than 133 degree, I can use VV. In this case, my arc of contact theta s equal to 161.71 degree. So I will select this value VV. Select VV belt drive. Now we can go to the table. So this is our values. 163 it is 0.96 and 160 it is 0.95. I have to get that value for 161.171. So I will do the interpolation. So for 163, for theta s 163, our value is 160, our required value is 161.71. For VV belt, it is equal to 0.96 and here it was equal to 0.95. I have to find this value of K. For this case, I will do the interpolation. I will put the numbers 1, 2 and 3. 3 minus 1 divided by 2 minus 1. Third one minus first one. So 160 minus 163 divided by 2 minus 1. 161.71 minus 163 equal to, I can do the same operation in the second row also. 3, 2, 1. Third one minus first one. 0.95 minus 0.96 divided by K minus 0.96. After substitution, I will get Ka equal to 0.9557. Now I have all these values. power was given in kilowatts, power equal to 10 kilowatts. Ks I have found from the table. For type N, it was equal to 1.4. kW I have found from the equation, 2.82 kilowatts. And KL equal to 1.13. After substitution, I will get number of belt N dash equal to 4.59. So I will take the next whole number equal to 5 belt. So select. So inference will be select type B, length 4013 mm with N dash equal to 5 belt. This completes our design of V belt. Now, thank you for being safe in your home. Conserve your personal hygiene and fight against corona. Study well. Thank you.